Okay, just making sure the audio is working. It looks like it is. We'll go ahead and get started. So today's lesson is 9.6. And it is going, or sorry, 9.6 and 9.7, I should say. And it is going over the segment relationship in circles and circles in a coordinate plane. Okay, a couple of key things here, right? First key point here is that, well, when two chords intersect in the interior circle, each chord is divided into two segments that are called segments of the chord, right? It's kind of redundant at, whatever, right? It's a blank. Okay, it's a blank. But we have theorem 10.18 here, and that is the important thing. So we have segments of chords theorem, and really this is just on the reference sheet. So if you look at your reference sheet and you look at two chords, right? So this part right here, you look at two chords, you'll find it on the reference sheet. Okay. And just to be very clear about what this is actually telling you, right? I'm going to show you everything. Oops, hello. I'm going to show you everything as far as the pieces go. So here's AE, and AE is this blue. Similarly, we have, let's say this red, and red here is EB. EB's right there. Next, we will have, work with me. Not very work with me. We'll have green. Green will be this DE here. And then last but not least, we will have, let's say this orange as EC. Okay, so what we should notice here is that the pieces of our chords are actually the ones that are multiplying each other. So notice that we have the chord AB that's split into saying, well, AE and EB. And those are the parts that are actually going to multiply each other. The same thing is true for DC. DC is like so. And then DC is also split DE and AC. That's how it's split. And so you take those segments that are split together from the same chord, and then you multiply those two together. Okay, so that's the key thing about this theorem you need to make sure you know of. From here, we have some examples. I hope that a lot of these examples are somewhat easy. Okay, this is some really basic algebra, but we'll see what happens. Okay, so let's break it down. We want to find ML and we want to find JK. Well, in order to find ML and JK, we need to find the individual segments of the chord. So we get MN and NL. And that's going to be multiplying each other, right? Because we take the same segment or same chord, take the pieces of the chord and multiply them together. MN times NL equals the same thing for the other chord. So KN times NJ. Make sure that is a dot. And because I already know what those segments are, we're going to replace them. MN is x plus 2. NL is x plus 1. Kn is x. And Nj is x plus 4. And so from here, we are going to FOIL or do your box method, whatever you want to do first. We get x squared. Our outer, just x. Inner, it's 2x. And our last is just 2. Put that equal to the other side. The other side is a simpler one. It's just distribution. So we take the x and distribute it. We go x times x. That's x squared. We'll do x times 4, and that is 4x. We'll combine the like terms on the left-hand side. Keep the right-hand side the exact same because it does change. And we're going to get rid of our x squared. Okay, the way that we're going to do that is that if I subtract x squared on the left-hand side, I still have to do it on the right-hand side too, because anything I do on the left, I have to do to the right and vice versa. So, right with 2x or x to the second power, like so. They'll cancel on both sides. And what we're left with is 3x plus 2 equals 4x. And that is making it a lot simpler for us to do. Subtract 3x. Subtract 3x. We find that x equals 2. But remember, this is not my answer. This is just part of how I'm finding my answer. I want to find what ML is. Okay. ML, the chord, is equal to two things. Okay. Be very careful here. We are not putting it back into the equation that we just solved. We are not doing that. Okay. Because that was multiplying the two segments of the chord to find the actual x value. That's how we find our x value here, but it's not how we're going to find our ML value. Okay. The reason being is because ML is split into two segments. Well, think way back to unit 1 when we talked about segments and angles and whatnot. We had our first postulate. It was that segment addition postulate. So we're going to employ that here. We know ML is the same thing as saying MN plus NL, right? We already established that. We already kind of solved that. Well, if that's the case, then ML is equal to x plus 2 plus x plus 1. And because this is true, and I have my x values available, I'm going to plug in 2. ML equals 2 plus 2 and 2 plus 1. Super easy. We get 2 plus 2 is 4, 2 plus 1 is 3, and then 3 plus 4 equals 7. Okay, that should have been pretty easy. Next, we find our KJ or JK. So JK, we'll take the same approach. We know it's KN plus NJ. We know that JK is going to be equal to x plus x plus 4. And JK is equal to 2 plus 2 plus 4. Because I have this, I can add them together. 2 is just 2. 2 plus 4 is 6. 2 plus 6 equals 8. And that is my answer for example 1. Okay, I recommend you do this next problem on your own, see how far you can get. Do the best you can and whatnot. Okay. Once you've come back, we're going to take the exact same approach. However, it's going to be a little bit different, right? The numbers are a bit different, but the approach is the same. That's the important thing. Okay, remember that the approach stays the same, even if the numbers are a little bit different. So here we have A, B, and PQ that we're looking for. So we'll say BN plus NA is equal, or not plus, sorry, multiplying. Right, we're taking our segments apart, or chord apart, rather, I should say. BN times NA, and then QN times NP. I'll replace it. I get x times x plus 6 equal to x plus 1 times x plus 4. And I'll just do everything that I've done before, every skill that I know beforehand, and we're able to do this. So x squared plus 6x equals x squared plus 4x plus x plus 4. If you're a little confused on how I got the right hand side, I did just do my FOIL method. So that was my first, my outer, my inner, and then my last in that order. Okay. Combine like terms. X squared plus 6x will stay the same. X squared plus 5x is 4. I know my x squareds are going to cancel out each other. So let's go ahead and square that. I'm left with 6x equals 5x plus 4. And go ahead and get that 5x out of there. And what we're left with finally is x equals 4. For the fun part, go ahead and find your values of those chords. We know QP is equal to QN plus NP. So QP equals x plus 1 plus x plus 4 So QP is going to be equal to 4 plus 1 plus 4 plus 3. 4 plus 1 is 5, 4 plus 4 is 8. You get 13 as a result. We'll do AB. AB was Bn plus Na. And we replace it. X plus 6. 8b equals 4 plus 4 plus 6. 4 plus 6 is 10, plus 4 more is 14. And those two are my answers. I don't think there's any kind of relationship seeing that 13 and 14 are our answers here, and 7 and 8 are the other answers. I don't think there's a relationship. There might be. But for right now, just leave it as this. Just make sure that you solve it correctly. That's the important part. Okay. Here we have our next key point 2. Okay. So we have 3 new vocabulary terms. Well, kind of new, where we have what's called a tangent segment, which is the same thing as a tangent, just with endpoints. And the secant tangent, which really is just kind of a chord, but you can be secant with a chord, I suppose. And then we have the external segment. Okay, the external segment is the segment on the outside of the secant segment. Okay, so realistically speaking, tangent segment is an external segment, but we only associate it with the secant. Okay, so make sure that you know those 3 vocabulary terms, and I'm going to reference them as best as I can. And then we have a couple theorems. Theorem 10.19, I think this is definitely the most amount of theorems we've had in any of our units. So theorem 10.19 is here. This is what we do for segment of secants. Okay, so here is the 2 secants box on our reference sheet. So it shouldn't be too hard to find if we have ourselves a problem like this. Then theorem 10.20 is going to be this tangent and secants box on our reference sheet. Okay, so make sure you know the difference between those two. But one kind of key thing I want us to recognize here is that in 10.20, or sorry, there's 2 key things. I'll go 10.20 first. In 10.20, the only part that is going to be squared is the tangent, and it will always be the tangent. Okay, so make sure you are not getting that confused. Tangent is always the one that is squared. And something else I want us to see is that notice how we have EB, ED, and ED in those 3 locations. Each one of those 3 locations has the entire segment. So in 10.19, it is this entire segment times EC. Okay, so we get the EC from there. We get the entire thing from there. Okay, so make sure you are doing the correct notation, the correct calculation. Okay, I've seen a lot of students make mistakes, small mistakes, but big end results. So make sure you are not making those small mistakes. And the same thing for 10.20, that ED is the whole segment. So make sure that you are multiplying the whole segment times the external segment. You can see on the board here exactly what I'm saying. Okay. Next, we'll do some examples. I'll show you one of each of these examples. We will not do example B just because I don't think it's super worth it. But we'll do A and C. And so before we keep going, we need to ask ourselves, what is the graph giving us? What is the picture giving us? And work from there, just like the last section, just like the last unit, or not unit, the lesson, I should say, the last lesson. So you need to identify our chord, our secant, our tangent, whatever the case may be. In this case here for A, I have 2 secants, so I'm going to use the equation for 2 secants. But what the equation for 2 secants tells us is that we're going to take the external segment, in this case RP, then we're going to multiply by the whole segment, RQ, and put that equal to the opposite secant with its external, RS, times the whole segment, not S, RT. And that's how we're going to solve this. The left-hand side should be pretty simple. RP is 9. But this is what I was talking about earlier. A lot of students are making this mistake, so make sure you're not doing the same. A lot of us are going to see that we have to multiply RQ and immediately think, see, oh, I have to use this 11. That makes sense. No, you are not using that 11 by itself. You want the entire chord. 11 only represents what's inside the circle. That's it. But RQ is what's inside the circle and outside the circle. So we do what we would normally do, right? The simple thing. Just add the segments together. We know 9 plus 11 is going to be 20. And then we do the same thing for the other segment, the other secant line. 10 is RS times RT. And RT is kind of a blank for us because ST is X, and that doesn't really give us a value. But what we do know is that RT is composed of RS and ST. You combine them together. So what we're going to do is we're going to combine them together. 10 plus X, just like so. And we're going to combine like terms. We're going to simplify and all that good jazz. Get 180 from 9 times 20. We'll distribute the 10, the 100 plus 10x, because we've multiplied both parts. Subtract 100. We're left with 80 equals 10x. Divide the 10 out. You get x equals 8. Okay. Very, very simple. Nothing too difficult at all. Okay. Now, of course, you can check your work if you plug 8 back into the equation that you just plugged in. Right, so you plug in 8 for this x here. That would work. Okay. That is our answer. So no need to fret. Now, what we'll do is we'll go to the next example. Again, we're skipping over example B. And here it's a little bit different. It's asking us for the radius of the aquarium. And I think a lot of us kind of got mixed up on that because maybe it's just a new question and we haven't seen it before. But really, we actually have, just not in the way that we've seen before, or like necessarily associated with it before. Okay, recognize that BC, this is our tangent. And then CD, that is our secant. Okay, so even though it's the diameter, or at least that's what DE looks like to be the diameter, and it is, make sure that you are using it correctly. Okay, identify the secant by 2 points on the circle, identify the tangent by 1 point on the circle, and then chords, of course, are going to be on the inside. So make sure you don't get that mixed up. But from there, we will then say, well, got to use my other equation, my tangent secant. That's the one involving my tangent squared. Well, I'll say BC, it's got to be squared. And that is equal to EC times CD. Just like this. Plug in the numbers you know. We have 20 for BC, 8 for EC, and then CD, well, it doesn't really tell us. It does tell us that we have an R and an R. Remember, right? We're looking for R. So we're going to keep that in there. Okay, that's what we're looking for. And how many R's are there? There are 2. We'll put 2 R's. And not forget, we're not looking at ED. We're looking at CD. And 2R is going to add to 8 here. Okay, because CD is all those pieces together, all those pieces added up together. And now we're able to evaluate. 20 squared is 400. 8 times 2 is 16R. 8 times 16, or 8 times 8 is 64. And we will just solve as normal. So 336 equals 16R. R. Divide the 16R out, or not the R, but divide the 16 out by 16. We get R is equal to the value of 21 there. Okay. Now go ahead and try the next couple of problems on your own. Identify whether or not you are dealing with a tangent secant or a secant secant, and sometimes even a tangent tangent. And make sure that you are doing this on your own first though. But if you are unable to figure it out or you need to check your work, go ahead and come back. In example 2, we are here to find our x value, and we do have a secant secant. Okay, we know that because we have 2 of these segments here that cross at 2 points on the circle and not just 1. So we're dealing with secant secant. Let's go and solve it. RS times RT equals RP times RQ. Look at the things we know. RS is 4, RT is going to be 4 plus X equal to RP, which is 3 times, not 9, sorry. See, be careful, not 9. RQ is 12. Be careful. So here we just solve for X. 4 distributed into the 4 plus X, 16 plus 4X equals 36. Factor both sides of the 16. You get 4X equals 20. Divide by 4. X equals 5. And that's it. Pretty easy. Then we have B, the next one in B. Here we definitely have a tangent secant because we have a line that only touches at one point. So we'll take WX, square it, and put it equal to our secant, which the secant is XY, times XZ. And forget it's XZ, the whole segment, times the segment on the outside, the external segment. We'll look at what we know. We don't know what WZ is or what WX is. We'll leave it as X. XY we know is 12. And then XZ we know is XY plus YZ, which is going to be 27. And so when we multiply that 12 times 27, we will get 324. Root both sides. X is equal to the value of 18. Okay. Move on to the next problem. Here we still have a tangent and a secant. Exact same approach as we did in B. So UT squared equals our external segment of our secant line or segment. That's going to be BU. BU, that's very clear, times our UW. Plug in what we know. UT we know is 3. So 3 squared equals VU, which is 1, times WU. Oh, that's funny to say. WU. Huh. I think it's funny to say WU. That's weird. WU. All right, whatever. We'll take the exact same approach as this last problem where we had to add the 2R plus the external segment. So 2R plus 1 here I get 9 on the outside. 1 times anything is just itself. So 2r plus 1. Subtract the 1, subtract the 1. 8 equals 2r. And last but not least, r. And from here, it'll be a breeze. Yeah, I think this is the super algebra heavy stuff. From here on out, it'll be some minor algebra. Still a little difficult for some of us, but some minor algebra. Okay. On this key point, okay, that box right there is on the reference sheet. It is your equation, the standard equation for a circle. Okay, that is the simplest, most bare bone equation for our circles. And that right now is what we need for our quiz. We're going to need that for our other quiz. We're going to need that for any future X tickets. Yeah, we plan to do. Oh, excuse me. Okay. So, couple key things to know. On the right hand side, the center, right, is H and K. Okay. Make sure you know that. The center is H and K, where H is the X value and K is the Y value. Notice that we have X minus H and Y minus K. That is on purpose. Okay. If you have a negative center for your X or Y value, you will then change it to a positive. Okay. If it's already positive, leave it alone. There's no need. Just leave it alone. Okay. And the last thing, X and Y will stay as variables. So really your equation is only looking for 3 things, which 2 of them come in one part. So you're looking for a number for your X, so your H value. You're looking for a number for your Y, your K value. And you're looking for a number on the outside that everything's supposed to be equal to. That is your radius. Okay. So you really need to find 2 things, center and radius. That's it. Because once you found those 2, you can make up any single circle possible. Okay. So if we have this problem here where we have to use the standard equation or write the standard equation of each circle and the circle shown to the right, here's how we can identify our radius and our center. Okay. Take your pen or pencil. You're starting at -3 and you're ending at 3 from one end on the left-hand side to the other end on the right-hand side. And you're going to go directly into the middle, and that is where your center is. So, well, if I know I have -3 and 3, well, if I add them together and I average it out, I get 3 plus a -3. Average it out, I get 0/2, which means 0. I have a center at 0, 0. And that is still going to work even with our Y value. We have a +3, then a -3, the exact same numbers. It's going to work out. So our center is 0, 0. We'll find our radius now. But remember, the radius is the segment between the center of the circle and a point on the circle. So any point from the center to the circle is going to be called our radius. So if I take this center point and I say, oh, well, let's go this direction. That's our radius. Oh, let's go this direction. That's my radius. Okay. Those are all the same radii. But there's actually 4 places that you can go that is guaranteed to give you a radius always, always, always. And that is going to be these 4 directions. Up, down, left, and right. That is your guarantee to find any radius possible. So take your pen, go to your center, hop, 2, 3. Since I made 3 hops, my radius R is equal to 3. And that is using my right way to go. Right, so using right there. but it will work for left, it will work for up, it'll work for down, doesn't matter. Okay, don't waste your time trying to figure out the distance formula or anything like that. It's much easier to go up, down, left, or right. Okay, don't waste your time at it. But I have my center, I have my radius. And now what I'm gonna do, I'm gonna write the equation. Anytime you're trying to write an equation for a circle, this is what I recommend. Already start out with it pre-filled. So I have x minus whatever squared plus y minus whatever squared equals something squared. And from here, you can just plug in those little pieces that you know. We know our center has an h and a k value. And I know that 0 is going to be my h value, therefore I can write 0 in here. Same thing with our k value, and my radius is 3. And now I'm going to simplify. X minus 0 is just x. I'm left with x squared. Y minus 0 is y. I'm left with y squared. And then 3 squared, of course, is 9. And that's my answer. That's it. So seeing it on a graph, I think is incredibly easy, but I think even seeing it and writing is even easier, right? It already gives me everything I need. So write my skeleton, x minus something squared plus y minus something squared equals something squared. I don't know what all those things are quite yet. At least if I was just doing this haphazardly. But now that I know what a center is, I know what a radius is, I'm just going to go ahead and plug those in. Remember, h, my k, my r value. Okay, x minus 0, y minus a negative 9, but remember, negatives are going to cancel each other out. We're going to have positive 9, and the radius is 4.2. Here, just simplify as much as you can. X minus 0 is x. We're left with x squared, which is not equal, plus. And now here's the trick. Okay, a lot of us are going to think, oh, y plus 9 squared, that quantity squared. I have to FOIL it out and figure out what all those values are. Hold your horses. No, do not do that. You're going to make things a heck of a lot more complicated for you later on. So just leave it like this. Okay, just leave it like that. It's fine. Trust me. Just leave it. But from here, I get 4.2 squared, and 4.2 squared is going to be 1764. And that is my equation. That's it. I'm done. Okay. Go ahead and try extra example 3 on your own. Okay, once you've come out back, let's look at the problem. Actually, sorry, one quick thing I want to add here. Hello. I just did it again. One quick thing I want you to add here is I want you to put a little like bracket here and then leave as don't FOIL. Okay, that's it. That's all I want you to add. Now we move on to the next problem. Here we're trying to write the standard equation for each of the circles. And this circle, unfortunately for us, is not quite at the center. It's not at 0, 0, so it's a little bit of a bummer, but that's okay. We'll take the same approach. We know we're here, which is -9. And we go all the way up to here, which is -1. We'll find the middle point between the two. So -9 plus -1 over 2. -9, or sorry, -9 plus -1 is -10. Divided by 2, we get -5. So this should be our middle point. Okay. Which is our -5. Do the same thing on the other side. We know we're at 0. We go all the way up to 8. Well, 8 plus 0 over 2 is equal to 8 over 2, which is 4. So this is my y value for my center, which therefore means that center is -5, 4. So already first thing check, center, good. Now I just gotta count my radius, but remember, use the trick like we said before, up, down, left, right. Doesn't matter which one you do, but as long as you find your radius, you're all good. Left, down, up, right. So we'll take the right. 1, 2, 3, 4. R is equal to 4. Okay. R is equal to 4. So now that we have our radius, oh my gosh, I don't know why this is not working so well. We have our center, we have our radius. Go ahead and put that into our equation. X plus, in this case, right, plus 5 squared plus y minus 4 squared equals 4 squared. And because, right, because I already have these simplified as far as I can do it without foiling, I'm going to leave the entire left-hand side alone. I'm going to copy it back down. But I'll do my 4 squared, which is 16. That's it. Okay. We'll finish it off, or finish off the next one. I have about 5 more minutes. Okay. A center at the origin, that's pretty easy. Plus 0. Really, I'm not even going to do it. We have x squared plus y squared equals what 3.5 squared is, which is 12.25. Okay, it's just not even worth it. Okay. Here is another equation, or another setting up an equation, and it gives us this point here, this -5, 6. It wants us to figure out what this is here. But remember, if it says that -1, 3 is the center, and I can very clearly see that, you know, this is my radius, I could set this up as a right triangle, right? I have a 3, then I have the 4 units here. And this looks like a Pythagorean triple, and it is, right? We have a 3, 4, 5 triangle. But don't get it twisted, all right? Don't get it twisted. We do not need to do a Pythagorean theorem here if it's on a graph. No need for it, okay? Because I can just do this. 1, 2, 3, 4, 5, r equals 5. That's it. No need. No need to do Pythagorean theorem here or distance formula. Doesn't matter. So write the equation as we would normally do. So x plus 1, right? That's part of my center squared plus y minus 3 squared equals r, which is 5, squared, which is 25. And that's it. That's my equation. Now, the trick with counting, it only applies to, well, a horizontal or a vertical line. Okay, it only applies to our up, down, left, right on a graph. But if you look at a problem like extra example 4, we can't do that. We don't have that trick. We don't have a circle here. We don't have a graph. So we have to use distance formula, which, to remind you, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, like so. But I'm not looking, well, I am looking for distance, but I'm looking for radius. I'll change the d to an r. And I'm going to treat 4, 1 as my x2, y2, and 1, 4 as my x1, y. So r is equal to 4 minus 1 squared plus 1 minus 4 squared. And I keep evaluating it further. I get 3 squared plus -3 squared. I get r equals 9 plus 9. And I'm finally left with the square root of 18. Okay, here in unit 8, we talked about simplifying radicals. And this is true. this radical can be simplified, but hold off on that. Okay, you're gonna hold off on here because realize later on we're going to square it anyway, which means it's going to cancel. So here, leave as is. Unless it's already like a perfect square. So if it's like 64, for example, leave it alone. Leave it under that radical. If we already have enough information to build our equation, x minus 1, that's my center, squared, plus y minus 4 for my center, is equal to the square root of 18 squared. Those are canceled. Done. Out of here. X minus 1 squared plus y minus 4 squared is equal to 18. And that's it. We're done. Okay, and that is the bell. I'm going to finish up on this problem real quick. So you're going to skip your example 5. That's actually both example 5s on your notes because I don't think they're very good questions. But I did make up my own example 5 just so that we know how to graph it. Okay. Remember that we can still identify our center. This is our H. This is our K. And so if our H is positive 4, it actually means a negative 4. Always remember it's X minus H. And we have our 3 normally. But then we take that 16 and we take the square root of 16. That equals 4. And that is our radius, R. So our center, negative 4, 3. So go to negative 4 of 3 units right there. And go up 4 units in left, right, up, and down location. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So these are all points in my circle where we have that straight line of distance rather than a diagonal. And we're just going to do the best that we can to make our circle. And that's how you graph a circle. And that's it. Okay. Alrighty then. I have to go. I need to set up for my next class, but I hope this was very informative and I hope you had a good time in the lesson. Let me make sure that this is all doing good. Need to stop recording and I'll see you all later. Bye bye.